All right, more fundamental theorem of calculus problems. At the end of this lesson, you will also be able to evaluate a definite integral using the fundamental theorem of calculus. Example 5 is finding the integral from -3 to 3 of 5 minus the absolute value of x dx. If you recall, in a different unit, when we just started learning about integrals, we actually did this one by, you don't need to write this down, just kind of look. We did this one by looking at a picture, something like this, and then we evaluated the integral from -3 to 3. So actually what we did on this one, we just found the area under the curve. So that would be the number one way that I would suggest to do this problem, is just get yourself a picture going and go from there. Okay, however, we could work this a different way using the fundamental theorem of calculus, and I would like to show you that way as well. So if I were going to use the fundamental theorem of calculus on this one, the first thing, since there's a minus sign, I would separate it into two distinct parts. Okay, to get the first part, we know that the integral of 5 is just going to be 5x. I'm going to evaluate it at 3 and -3. 5 times 3 would give me 15, minus 5 times -3 would give me -15. And so that part of the problem is going to equal 30. Okay, to do the next part of the problem, we are going to actually deal with an absolute value of x, and absolute value of x is a little bit tricky because it actually v's, and there's one point where it's actually, you can't even take the derivative because there's the integral, because there's a sharp turn. But what we are going to do, and there's no rule or anything for the absolute value, so I'm going to actually split this into two parts. The absolute value of x, hopefully you know, looks like this. So it changes direction at x equals 0. So I'm actually going to slice this one in half. So I'm going to go from -3 to 0 of the absolute value of x. And actually, I'm going to drop my absolute values, and I'll tell you why in just a second. And then I'm going to add from 0 to 3 of x. Okay, the reason that I'm dropping the absolute values is because both of these are just lines. They're both just the line x, and if you notice on this one, actually, this would be the line -x, so I'm actually going to put a -x there instead. And basically what this is doing is just taking care of the absolute values. All right, so just evaluating this now, we still have that minus sign sitting out front. Now I'm just going to evaluate each part. So the integral of -x would be -1/2 x squared. I'm going to evaluate that one from -3 to 0. And then the second one, the integral of x would be 1/2 x squared, and I'm going to evaluate it at 3 and 0. So, okay, minus. Okay, if I plug in 0, I'm going to get 0, minus, if I plug in -3, -3 squared is 9, I'm going to get -9/2. Okay, and then plus, on this one, if I plug in 3, I'm going to get 9/2, and then minus 0. Okay, so this will turn into plus, so I'll get 9/2 plus 9/2. So I'm going to get 30, minus 9/2 plus 9/2 would give me 18/2, which would give me 9. And then 39 minus 9 gives me an answer of 21, actually. Okay, so I get an answer of 21. So that was just a different way of working it. And again, notice how lengthy that way was using the fundamental theorem of calculus. So if you are able to draw a picture, your life is much, much easier. But I did just want to show you another way of doing that problem. All right, let's try another one. This one says to determine the area of the indicated region. So you'll notice we have a picture, we have an equation, but we actually don't have an integral. And I could not use geometry because that is very much an irregularly shaped object. So what we need to do first is write ourselves an integral. This is going to start at 1, end at 2. My function is going to be 1 over x squared, and we'll put dx. All right, so now we get to use the fundamental theorem of calculus to solve this problem. So this will be the same thing as 1 to 2, x to the -2. When I take the antiderivative of that, if I increase my power by 1, it will add 1. -2 plus 1 is -1. Reciprocal on the outside is still -1. So if I rewrite this, this is going to be -1 over x. I'm going to evaluate it at 2 and 1. So if I plug in 2, I'll get -1/2. And then minus, if I plug in 1, I will get -1. Those turn to plus. -1/2 plus 1 is a +1/2. And notice that does definitely make sense. I got a positive answer, and my whole entire area is above the x-axis. So hopefully now you can still use the fundamental theorem of calculus to evaluate a definite integral.